In this problem, the hard sludge problem, you're told that a water contains, in this case, 34.4 milligrams per liter as calcium carbonate of CO2, carbon dioxide, 223 milligrams per liter as calcium carbonate of calcium, and 46 milligrams per liter as calcium carbonate of magnesium. You're told that all of the hardness is carbonate hardness. You're asked to use the stoichiometry of the lime soda ash softening equations to determine the daily sludge production in dry weight, kilograms per day. The plant is treating water at a rate of 31 milligrams per liter. I've simplified this problem by telling you to assume that the effluent water contains no carbon dioxide, no calcium, no magnesium, and the calcium oxide and soda ash are added in the exact stoichiometric amounts. Now, in reality, that's not going to be the case because we do treat to the practical limits, but you can, for this problem, assume that you have removed all of the calcium, all of the magnesium, and you've neutralized all of the carbon dioxide. So let's think about this. I'm going to solve this problem, or start to solve this problem for CO2. I'm not going to go through the full set of calculations, but I want to give you a sense of how to approach this problem. So our CO2 concentration is 34.4 milligrams per liter as calcium carbonate. We need ultimately to calculate the number of moles per liter. If we have 34.4 milligrams per liter as CaCO3, divide that by the equivalent weight of CaCO3, and that is 0.688 milliequivalents per liter. Now, CO2 reacts with water to produce carbonic acid. Carbonic acid can donate to hydronium ions, so therefore N is equal to 2 equivalent per mole, or milliequivalents per millimole. So if we have 0.688 milliequivalents per liter, we divide that by 2 milliequivalents per millimole. That is equal to 0.344 millimoles per liter. Now, some of you have noticed that you could just divide by the molecular weight of calcium carbonate. You can do that here, but only because CO2 has an equivalent number of 2, and calcium carbonate also has an equivalent number of 2. If that were not the case, for instance, Fe3 plus has equivalent number of 3, you couldn't just divide. You'd have to take this approach that I've used here. Now, if we look at equation number 1, CO2 reacts with calcium hydroxide to form calcium carbonate that precipitates NH2O. So if we have 0.344 millimoles per liter, we're going to produce 0.344 millimoles per liter of calcium carbonate. So you're going to need to do the same thing for these other reactions. Okay, we just looked at reaction 1, the neutralization of carbonic acid. You have carbonate hardness due to calcium, reaction 2, and carbonate hardness due to magnesium. So when you're doing this, make sure, look at the fact that your molar ratio for carbonate hardness due to calcium is 1 to 2. So for every 1 mole of calcium you remove, you're going to produce 2 moles of calcium carbonate. For carbonate hardness due to magnesium, note that for every 1 mole of magnesium, you're going to produce 1 mole of magnesium hydroxide, but you're going to produce 2 moles calcium carbonate. So make sure you're taking that into account. Well, once you find the number of moles of calcium carbonate, you can add up all of those. Need the molecular weight of calcium carbonate, the flow rate. You will also do the same for magnesium hydroxide. Look up the molecular weight. Okay, from that and your flow rate, you can ultimately calculate the dry weight of sludge produced. So hopefully this helps. Good luck. You've got this, I'm sure. And good luck finishing your homework.